The picture isn't half bad. I was doing some adjustments on the with the color controls in the back, so we got the color back a little bit closer. Still not right. There's overloading in places, and I turned it off and turned it back on, and I had a problem getting it to lock, not the color, but the actual composite video signal. So there's something funny going on in the tuner. But, yeah, not so bad. This is encouraging. I have spent some time just kind of doing a preliminary adjustment on convergence, and the convergence panel works. Everything works on the neck of the picture tube, and so it's not so bad. The sound is terrible, though. The sound is absolutely terrible, and I fooled around with the buzz control, and it certainly isn't that. And when we go off channel, we have, let's go off channel. We got pretty full sound. Off channel is pretty full, so I'm not sure what that means. Yeah, this tuner isn't quite ready for prime time yet, but I've been kind of keeping track on this afternoon, having had it on for hours, and I'm a little concerned, more than a little concerned about this transformer. I mean, this is a deal breaker if this is not right, and it's hot. It's not even just warm. It's too hot to hold my hand on it. And I noticed that, I've been noticing that over time. And if that transformer just decides to give it up, I don't know if we'll ever find anything that we could replace it with. That's a big, ugly thing. But I just turned it off, and it is effing hot. So, I don't know about that, unfortunately. And also, I'm not sure. Now, I'm not sure if this is just the ambient temperature of all the tubes. This is turned off. I'm going to unplug it. The high voltage cage is hot also. I can put my hand on it and hold it for a few seconds, but it's hot, understandably. And the chassis itself, the sheet metal is warm, maybe even hot. And then these capacitor cans back here, the ones that we changed, the new old stock that we put in, I can hold my hand on it, on the first one, the one that's out farther. I don't know which one, C1 or C2. And then the other one closer to the high voltage cage is hotter. I can keep my fingers on it, but it's very hot. So one is hotter than the other. That may have to be a recap job eventually, because there's some pretty crucial capacitors in that circuit, in some of the circuits that are part of those multi-section caps. And maybe that's even part of some of these picture problems. We don't know. Our horizontal output tube, everything's hot right now, but that was not a new old stock. That's an old 6LF6 that we've been using as a test. So I do believe that with a new old stock horizontal output tube, it'll improve things very much so, but won't do anything about that sound issue. That's so we got the tuner and the IF strip to explore, and this transformer, though, that's yikes. That's a yikes. It is hot AF. I can't put my hand on it for more than a few seconds. It's as hot as a tube. So I hate to think that this is going to do us in on this project. Oh no, did you really take this apart again? Yeah, I guess I did. Well, I had convinced myself that it was a mechanical connection, that it was the interface between the tuner strips and this series of brushes or contacts. And if we look inside, it's yeah, they're pretty tarnished and they're pretty worn too. And I just thought I should look at it again and see if we can do something about something. Because I think that that's part of what it is. If we take our turret tuner, also looks like a piece of corn on the cob. If we just flick it back and forth between channels, it usually responds, which tells me that it's just a mechanical electrical connection that isn't quite right. So I was trying to take this whole assembly apart with a minimum amount of disassembly, and I think I might have to take this off. And that's not really a problem, except that there are these circlips. There's one here. I'd take one off for the gear, but there's a 95% probability that when you try to take it off, it's going to shoot across the garage and you're never going to see it again. And I don't have any spares, so that's the one reason why I didn't want to take it apart. But you have to take a lot of stuff off to get the turret out. So, all right. So we're gonna look at this, see if we can find a solution to make this better, cleaner. Shimmers like a jewel now, best I could get it. So yeah, there's a lot of junk in there, and I'm kind of embarrassed to even say this, but I use Tarnex. I never thought of it. I didn't think of it until I started doing this. I thought, well, I'll try some Tarnex. It just took it all away, and then I cleaned it off with water and then alcohol. So it seems to be about as good as it can possibly be. You can see the wear on the contacts. They are very easy to deform unintentionally, so I think I got everything back in place. And I don't know if you can see it, but right there, that clip right there, that contact clip right there, there's a hook at the end, and it's intended, I think, and they're all like that, it's intended so that you can turn the turret tuner either way without running the risk of bending this. So you can turn the turret this way, and the contacts over here on the channel strips would go top to bottom. But if you turn the channel the other way, that, I guess, is intended to, that little hook is intended to keep it from bending. So I think it's all right. It was about a 2-hour round trip to take it out and take it apart, and I mean, we got a lot of grime off, tarnish and grease. So I'm gonna put it in the cabinet. We're just gonna kind of set it in the bottom, hook it up, pretty straightforward, and just see how it works before we make any judgments like putting it back in place. Well, I've just got the tuner tacked in here. It's plugged in, B+ filament AGC. The output, this is AGC voltage, and that's what that number is. So I thought we would just kind of monitor the what it does on and off channel. I'm not sure what to expect. I don't know if I believe it's working properly. So, okay, let's see if we have a picture. I think I've tuned the tuner into channel 4. And, uh-oh. Wah, Still not good. What channel are we tuned into here? Channel 3, okay. Let's switch it to channel 4. I don't think that is better news, I don't think. That looks pretty horrible right there. Let's see what we can learn. If we just click our channel back and forth. 1 click, back to 4. Okay. Well, it was only 1 click. It was only 1 back and forth click to make it come back. Looks like a little colorized Andy Griffith. That's not so bad. So, all right. Well, our tuner is back together. And I'm not sure how to comment on it yet. Maybe we just got to run it for a while. But let's look at this. This is our AGC voltage. How do we do this so we don't have a reflection? So that's 2.6 volts. If we go off channel, I imagine that voltage should get bigger, which it does. I don't know. We go on channel. And yes, we are on channel. That's channel 4. Off channel to channel 3. Channel 2. That would be like channel 13. So, okay. I don't know what I'm looking for or expect to see. This is the on-channel voltage, which you would expect that if you've got it on channel and the signal is strong. I'm not sure if the AGC voltage is, well, it says it's positive, so you'd think that a positive voltage, a high positive voltage on the grid would increase the sensitivity, and a lower positive voltage would decrease the sensitivity. Maybe it's working. Maybe it's working. So, all right. What about the sound? As awful as it was, it's hard to believe it's really that bad. But it is. So this could be our culprit deep inside the IF strip. And let's turn our fine tuning. All right, so I'm going to show you this and I'm going to zoom her in. So as I turn the fine tuning, you can see I'm turning it, well, whatever, counterclockwise, but all right. Well, that noise has got to be from antenna terminal. It's just a couple of alligator clips. Turn it too far, we lose our color. Well, so, you know, more good news. The high voltage works and our color locks back on now. Yay about that. That was a real bear to get that one to go. And it seems like it's kind of working. I mean, I'll turn it off channel, turn it on channel. It comes right back in. So I think our tuner's, look at that. We've got snow. Oh, our tuner's coming along. So we got to figure out the sound. It's terrible. Most likely not in the tuner. Okay, that's our AGC voltage right now. So if we pull this wire off, be careful this it's running. This should beats me. Oh no, that's not our AGC, that is our automatic fine tuning. Let's go back on here. Let's try that again. So it's starting up cold. Let's see how we do. Boy, it doesn't sound like it's coming in right. Yeah. It's like something from the Outer Limits. So yeah, this tuner still isn't right. And get my hand on here. I'll just see how many clicks it takes. Yeah, not good. Same problem as before. Started up better before. Wow, this is not good. There we go. All right. Once you get a picture, it's not bad. But so the picture really isn't that bright. And I'd say I have the brightness turned up a little bit higher than it should be, and the contrast, as soon as I turn the contrast up, the picture starts to bloom. It really, I don't know if that's just a sign of this picture tube, but the picture's pretty sharp when it's not that bright. That's the brightness. And I should probably not have the baseball game on. I should probably have some junk TV on. Well, here's some copyright-free material. Yeah, I have to say, maybe the AGC is working. This we used to have those bendy lines on the top of the picture, and it seems like it's kind of fixed itself. And the color killer is working. There's no confetti over here, so I'm not sure if we can improve our bandwidth with an alignment, but obviously there's something that needs to be aligned, and it's probably that IF strip. So that is, but this is encouraging, super encouraging. And it's not as humid of a day today, so the high voltage system is not sizzling like fajitas. It's pretty quiet. So the tuner thing, I don't know. Maybe we'll never get to the bottom of that. I'll try swapping tubes. I don't think it's tubes, but well, the sound is absolutely as bad as it sounds. It is not just it's not that the tuner's off the center of its frequency spectrum. The sound is barely getting through, and I even hooked up another speaker, thinking that maybe the speakers were totally wasted, but no. Okay, so based on what I learned in the Grob book, Basic Television, nothing basic at all about the information in this book. So the quadrature coil is part of the set, and if we go back to the section on the sound aspect of it, there's information on here. And long story short, finding the quadrature coil would be kind of the first step in trying to figure out this wimpy sound, because the sound here sounds like a radio station that's tuned way off to one end of the band. Well, back at Bernard Grob's book on page 652, Not So Basic Television, there's a section defining the quadrature grid, the FM detector, the audio circuit of a TV of this era. And Zenith used this particular tube in almost all of them of the day. This is a 6Z10, maybe a 6Z10 if you were somewhere else. But it is a dual pentode tube. And this particular tube is sort of designed for this purpose. One section of the pentode, or one pentode, is a sharp cutoff pentode. And where they say that, right here, a sharp cutoff pentode. And the other section is a beam power audio output stage. So the sharp cutoff stage of this refers to how little swing in voltage it takes to shut the conduction off on the tube. And the other half of this tube, the beam power, is essentially an amplifier. So if we go over to the Zenith schematic here, the 6Z10, this is half of the 6Z10. The other side is right here, the sound output. So this is an amplifier. Half of it is an amplifier driving the speaker, going through a connection that goes to the space command. And this section here is where we're going to kind of look at it today. This is the quadrature coil, and this is our buzz control. And it took me quite a while to stare at the Grob book. I mean, it's very detailed, very technical information. He talks about the small range it takes to cut off this tube from conduction. -3 volts for grid 1 and -6 volts for grid 3. So in the construction of this tube, there's 3 grids. It's pentode, so there's a cathode, 3 grids, and the plate. And grid 3 is the quadrature grid. That's what they call it, quadrature grid. And this is the quad coil. It's a coil with a low value capacitor, and it's intended to be the detector. This is the FM detector. So in a TV, the audio is frequency modulated. It's like an FM, kind of like an FM radio. The picture is amplitude modulated. So the FM audio doesn't have the kind of bandwidth that FM radio has. It's a shorter bandwidth, and the center frequency on the audio section in composite video is 4.5 megahertz, as opposed to an FM radio where the center frequency, the IF frequency, is 10.7 megahertz. So it's a different thing, but it kind of works the same. So in the Zenith, we were looking on the chassis. The quad coil is, well, it's right there. The quadrature coil is right there. And that's right next to the 6Z10. So that signal that's 90 degrees out of phase with the incoming signal on grid 1, the 90 degrees out of phase signal on grid 3 allows essentially half of the audio signal to get through the tube and go on to amplification. So in essence, it's kind of like what a detector diode does with amplitude modulation, where the either the positive or negative going side of that waveform is clipped off, and it becomes a signal that goes from 0 volts to plus, or 0 volts to minus. So that's how it gets detected. and thus then it goes on to the amplifier, and it gets amplified and shot out there. So this is the FM detector circuit, and the quadrature coil is what, when it's properly adjusted, you get basically exactly the waveform you want, which is from 0 to positive or 0 to negative, and not a mix of junk. And that's why when it's not tuned properly, it's out of resonance, you get, it sounds fuzzy and weak and like a FM radio station tuned way out there on one edge of the band. So the buzz control and the quad coil run in, well, they're a tandem. They work together. And in the case of this, well, this type of circuit, there's 3 grids. The signal comes into grid 1. The quad coil it sends a signal in resonance to grid 3. That is 90 degrees out of phase. It's in quadrature. And grid number 2 is a kind of a funky thing. So let's go back to Bernard's book and just briefly try to understand what this is about. So the signal comes in grid 1. Grid 2 has a bias voltage to it. And then grid 3 is the quadrature grid, and that runs 90 degrees out of phase with the signal on grid 1. So by putting a bias voltage on grid 2, according to Bernard, it becomes a quote-unquote virtual cathode. And that has to do with the space charge. So the space charge is the emissions from the cathode. Sends out a blast of electrons, and when you have grid 2 bias like this, this essentially becomes the cathode for the next grid. So that's how it's essentially like 2 tubes in one kind of thing. So cathode, signal, virtual cathode, quadrature signal, and then the output of that is going to the amplifier. The output of that is a detected audio signal. So the sound on this set is kind of like it's very weak, it's very fuzzy sounding, I guess you might say, but it sounds like a radio station that's tuned to the very outer band, and it's just scratchy, fuzzy, weak. And the quadrature coil, based on information we learned in not only Grob's book, but the Zenith books. I mean, I've put a lot of time into just trying to understand this better. The quadrature coil is right here. It's right there. And I had some success with this. So what I'm going to do is put the our tuner device in here and turn it. So the slug on this quadrature coil actually still moves. That becomes a real problem with these older sets, that the slug or the tube itself, the cardboard tube, shrinks and you just can't budge it. So I'm going to turn this up a little bit, and we're going to turn it, and I'm going to show you that it had some pretty solid success. This is just the quadrature coil. Watch it as I turn it. Listen to it.
Telling shows on school, we had a briefly out of thing, and then immediately out into gear, I think we're engaged. And then we all were at.
It's booming. Now, let's go to our long skinny screwdriver, and here's our buzz control.
I would assume they did. If they had kids back then, like their daughters would be hot right now and like probably 25. You know what I mean?
They'd be a lot older than 25.
Oh. Yeah, they'd be like 40.
What's wrong with 40? 40 is the new 25. It really is. It is.
Vapors.
Booming sound. Absolutely booming.
Dayquil Vapor Core. The vaporizing daytime coughing.
And the funny thing is, this pot didn't work very well. It sort of fixed itself.
High floors.
There was a period of time when I was fooling around with this where I couldn't get the volume to go anywhere other than full blast, but it seems like it's come around. Getting this old set, this one, back
Selena Gomez.
into running condition seems to just be a slow slug, a long process.
Oops.
I hooked up the,
I'm a lifelong Republican, and I voted for Trump twice.
oh boy.
But I can't
You know
do
what,
it
look
again.
at this.
Trump
crap.
wants a national sales tax on imported
This
goods.
guy,
It'll make
this guy isn't a
everything more
lifelong
expensive for
Republican,
regular
he's an
people,
actor.
all while giving tax breaks
He's
to
an
billionaires.
actor. They get paid to say it's hot, and I'm not going to touch it. That's the thermistor. That is for the degaussing circuit. I happen to... I was going to put a CL90 in there, but I found one of these, a couple of these on the interweb for just a few bucks. So that should work. Seems to work when we turn the set on. The degaussing coils, I hooked them back up, seem to work very well. So slowly making our way to victory here. Have not hooked up to Space Command yet. Not that important. Everything's bypassed, so we're going to leave that alone until it's important. But well, it's working again, and it looks pretty good actually at this point. Trying a different channel, something other than the political garbage on the air. But I came out the other night, I set the TV down, I was going to watch a game of the World Series, and all I had was sound. And the picture looked like that. And I had sound.
I'm not sure, but we're not going to give up.
And all I could see was just a hint of chroma coming through here. Brightness control didn't work. Contrast was irrelevant. Wasn't the tuner. Jiggle, jiggle. All I had was sound and just the faintest glow of chroma. So, what do you do? You know? So I knew that because I had those things, the IF strip was working. We had sound coming through. And because that there is a hint of chroma, there was, well, the IF strip, the picture was working. It was coming out and it was feeding into the chroma demodulator up here. And the problem would obviously, to me anyway, would have been in the luminance circuit. That's the 12 HL7. That's the final video amplifier, the output amplifier, and then right in there is the transistor. That's, well, I guess it's called either the video amp or the second video amp, depending upon whose literature. So I figured that this was going to be, well, I didn't know, and it was on its feet, so I only had access to the top at the time. It's kind of a beast to move this thing around, to flip it upside, flip it on its side, or flip it back on its feet. Had all the test gear around it, so I kind of got into it, and eventually we got it to work. So what I started with was looking at some signal injection. So I took the output, the drive output from the Syncor, the VA48, and I fed, took the IF out and ran the IF output into the IF input. So I took the tuner out of the equation. Why not? And then with that, it's easy enough to poke around in the signal path to get to see where the signal comes, where the picture comes back from the signal. So coming over here, well, this is the SAMS, as we've talked about before. Here's the Zenith schematic, the Rosetta Stone, telling the same story in two different languages. So let's just go to the Zenith schematic, because in this particular case, I like how they have laid this out. So let me talk you through this. This is the IF strip. So these dotted lines that cruise around here, that's the enclosure of the IF strip. And right here, that diode, X1, is the video detector. So the video comes out of the IF strip here. That's the first test point of that point. Here's the 4.5 megahertz audio trap, which would, when set properly, eliminates the 4.5, well, it's a 4.5 megahertz trap. It eliminates the audio component of the video signal from contaminating the picture. And down here, for what it's worth, which is worth a lot, this is the output of the audio. So that's the audio detector diode out of the signal. Comes down here. So, but we're just going to talk about the picture. So I knew that we had, it could inject a signal right there, pin 2 of the 12HL7 amp, the luminance amp. I could see a picture on the screen, just a crosshatch. It's a monochrome image. At this point, we're downstream of the color demodulator, so if I fed color bars into it, it would just have some wacko color thing in it. So we're just looking at monochrome picture. I can see a picture there. If I put the scope on, megascope on this point, I could see the video signal. I could see something like this, but its level was way down. And while I was clipped into this point with the scope, the voltage reading was completely wrong. It was a negative. This, both the Zenith schematic says it's supposed to be over 8 volts, and the SAMs, I think, even says it's going to be 10 volts there. Yeah, 10 volts. So I assumed that it was biased off. That was the reason why it wasn't allowing a picture to go through there. And then this is our transistor we just looked at. That's the, well, they call this the video driver. I think the SAMs calls it the second video amp. So different nomenclature, I guess. And then before that is the delay line. Zenith doesn't make a big deal about it in their schematic, and that's driven by this cathode follower. And that was our 4.5 megahertz trap and the output of our IF strip. So from the output of the IF strip to the output of the video amp, and thus to the cathodes of the picture tube, it's really not a very long and complicated signal path. It's pretty straightforward. So how hard could it be, right? So you might be thinking, hey, this transistor's no good. Well, it was fine. I'll show you where it is. Well, we looked at it a second ago. I took it out. It's a socket-mounted transistor. It's that one right up there that has the red and black Sharpie marks. It was fine. I checked it on a semiconductor checker, and I checked it on the old DMM in diode mode. I tested the junction between the base and the emitter and the base and the collector, and it's fine. Okay, so it's not that. And I even replaced it with a modern transistor. And beware of doing stuff like that. I don't know if that has diminishing returns. I mean, once I got the whole thing working, I put that new transistor back in it just to see what happens, and it had probably 4 or 5 times the gain that this one had. This Zenith branded transistor from the day had just doesn't have as much gain as these new things do, and it overloaded this whole luminance circuit, and the highlights were clipped. It was really ugly, and when I put the old one back in, once I got this working, it was just fine. Looks really good, actually. In the frame here are the two things that didn't work right. I realized that the bias here on this grid comes from the brightness range pot. 24 volts comes in, goes into the wiper of the pot, and then into the well, this is the brightness control. and it comes out of the brightness control and into the grid. So the brightness control modulates the signal that flows through this tube to the output based on this voltage. So when it's a negative voltage, it just biases this whole thing off, nothing gets through. And when it's at this range here, at this roughly this position, it works like it's supposed to. And as you change the brightness control, yes, this number will change a little bit. So yes, I did not look at this until the next day. It dawned on me that, you know, there could be a dead spot on this brightness range pot. So first thing I did when I turned it on is I stuck the long skinny screwdriver in the hole, because that the brightness range pot is down here inside. So you got to get back into it with a long skinny screwdriver, and sure enough, it was a dead spot. And that's why it just sort of like one day decided it was going to pop off and stop working, because there was a dead spot that had, I don't know, arced or something into the resistive element. And as soon as I jiggled it, came right back to life. So once we got the brightness working again, this bias voltage came right back up to where it should be. But we still had deficiency in the collector circuit of this driver transistor. And that wasn't right. It was higher than 2 volts, but it still wasn't right. And so I got into looking at a bunch of these resistors in this circuit here. And specifically, I kind of zeroed in on this one. I would call this the bias resistor for this transistor. And this is a 120K, 120,000, 1 watt, 120,000 ohms, 1 watt resistor. 10% resistor. It has a silver band. In fact, there's a lot of resistors. A lot of resistors in this set actually have 10% tolerance resistors in it. And it just so happened that this is the resistor from it. Brown, red, yellow. So 1, 2, 0, 0, 0, 0. 120,000 ohms at 10%. So if we were going to just take a look at this resistor, it should be 120,000 ohms, 1 watt. And it's not super horrible, at least at first appearance. It's 156,000. But what is that really? That's, well, let's say 120,000 ohm resistor. 10% would be 12,000 on the upside. So that'd be 132,000. And it's 156,000. So that's over 25% higher. So definitely too high. And that would explain completely this incorrect bias voltage right there at the collector. So let's go over here and look at it. So right there in the middle of the picture is the bottom side of the transistor socket. And right down here, that new resistor is the one that we changed. That should have been 120K, so we replaced that one that we just looked at with this resistor, and it brought everything right back up to where it should be. So, and I also wanted to sort of point out, you know, this chassis, there's 10% resistors all over this Zenith chassis, and I don't recommend just randomly changing resistors because they're over 10%. If the circuit works, I think I would tend to leave it, because you start changing a few things and then suddenly you end up with a disparity in tolerances in other parts of a circuit. So, you know, I guess my sentiment is that we just will wait until something is demonstrated that it's not working correctly. That control pot back there, the brightness range pot, had a dead spot, or still has a dead spot on it, but I just jiggled it past that point, and it restored the function of the video amp, the video output amp, and the brightness control. So everything in the tube works fine. And this resistor that was out of spec, and there could be plenty of others that are out of spec, this resistor, I wouldn't have ever found that had I not been poking around to solve another problem. 9 times out of 10, when you try to read resistors inside of the circuit, you get false readings. And this particular one, I think it read like 9 or 10,000 ohms until I lifted one end of it out of the circuit. Then it revealed what it really was. So, you know, with things like this, if you have enough lead on the component, you can snip it, read it, and if you plan ahead, you have enough room to make 2 hooks, one on either side of the lead, and you can hook it back together, crimp it, and then solder it. But it's a process. You have to be able to do that. You know, things like this, there's room. But, well, there's plenty of examples. Down there, as an example, you just don't have the lead length to get in there and snip it and expect that you can hook it back together, solder it back together. You can't really just dab solder on both ends of it. I mean, you can tack it in there, but that's not a permanent fix. So, yeah, with these hand-wired chassis, inspecting the resistance of components is kind of an arduous thing at times. I mean, even the resistors like this really don't have enough lead length to snip it, read it, and then hook them back together. So, you know, sometimes a little coil of wire, a few wraps of wire between the 2 ends, and you can solder it. That helps, that works. But that takes time. That's, you know, 5 minutes per component, maybe even more. And, you know, just once again noting that there are silver banded resistors everywhere in these chassis. Almost all of them are 10%. And, but you gotta lift them from the circuit to really have an accurate measurement. So it's just weird. I was lucky to find this down there. So we've had the set running for about an hour, maybe even an hour and a half, and it's working pretty well now. I mean, it's really humming along, I'd say. And what's the next step here? I think the next step, we have the sound that works now. We adjusted the quad coil in the sound to fix that problem. Still trying to deal with a sweep generator. I ordered one off of eBay. When that arrives, we'll see if that one works. But I think maybe the next step at this point is to sort of begin the restoration of the cabinet, take the chassis out. The plan is to, I can take the tuner assembly out, the motor assembly of the controls. I was going to modify the cabinet a little bit, make it a little bit, well, I think it's ugly, and I thought I could do something to make it less ugly. So, and then I've got to deal with the CRT, so we'll take the CRT out. I have a new all-stock chroma color from the early 70s that would be ideal for this. But I would probably take this one out, and we know that it works, and not take the cataracts off of this one right now, put the other one that I have in here. So it's a whole restoration process that's going to be, but for the most part, it's working. It really came back to life nicely after we did all the work on the high voltage. That everything works really well in that. So no clicks or pops. And I expressed concern a while ago about this transformer being hot. I mean, it does get very hot, And although I have another Zenith chassis of this vintage, and that one gets pretty hot too, so, you know,